Somewhere beyond Neptune, far past the last familiar planets, something may be hiding in the dark. Not a small asteroid, not a lonely comet, but a massive unseen world moving so far from the Sun that even our strongest telescopes have struggled to find it. Scientists have not seen it directly, yet something strange is happening at the edge of the solar system. Distant icy objects are moving in patterns that look too organized to be random, as if an invisible planet is pulling on them from the darkness. They call it Planet 9, a hidden world that could be 5 to 10 times heavier than Earth, orbiting hundreds of times farther from the Sun than we do. If it exists, it is not just another planet. It is a gravitational ghost silently shaping the outer solar system and pulling distant objects into strange paths. Before we begin, write in the comments where you are watching from and what time it is in your country right now. And if you enjoy calm journeys into the mysteries of space, subscribe to Theories Before Sleep. Tonight, we travel beyond Neptune to search for the hidden planet that may be pulling our solar system apart. We think of the solar system as something still, a quiet family of planets circling the Sun, Mercury rushing close to the fire, Venus glowing behind clouds, Earth turning gently under oceans and sky, Mars waiting cold and red, Jupiter, Saturn, Uranus, and Neptune moving slowly through the dark. From here, everything feels arranged, everything feels balanced. The Sun seems like the center of our little cosmic home, and the planets seem to move around it in a pattern that has lasted for billions of years. But that is only the local picture. The solar system is not standing still, it is moving. The Sun is carrying every planet, every moon, every asteroid, every comet, every spacecraft, and every human life through the galaxy at enormous speed. Earth does not simply orbit the Sun. The Sun itself orbits the center of the Milky Way, dragging the entire solar system with it through a vast ocean of stars. Even as you sit quietly tonight, Earth is rotating. Earth is orbiting the Sun is orbiting the galaxy, and the galaxy itself is moving through space. Nothing is still. Not Earth, not the Sun, not the Milky Way, not even the great clusters of galaxies beyond us. Everything is moving through a universe shaped by gravity. And this is where the mystery begins. Because when astronomers measured the motion of our cosmic neighborhood, they found something strange. The Milky Way was not simply drifting randomly. Nearby galaxies were not moving in scattered directions with no pattern. Huge numbers of galaxies, entire groups and clusters, seemed to be moving together, as if something was pulling them. Not something small, not a planet, not a star, not even one galaxy. Something much larger. A vast gravitational influence hidden in the deeper universe, pulling our region of space toward a direction we could measure but could not easily see. This invisible pull became one of the great mysteries of modern astronomy. The Great Attractor. The name sounds like something from science fiction, but it is real. Not a single object like a planet or a black hole waiting in the dark, but a massive gravitational region, an enormous concentration of matter, powerful enough to affect the motion of galaxies across hundreds of millions of light years. It is not pulling only our solar system. It is pulling the Milky Way. It is pulling nearby galaxies. It is part of the motion of thousands of galaxies flowing through the cosmic web. And for a long time, the most disturbing part was this: we could not see it clearly. The thing pulling our cosmic neighborhood was hidden behind the Milky Way itself. Our own galaxy was blocking the view. When we look into space, we often imagine that telescopes can simply point anywhere and reveal what is there. But the universe does not work that easily. The Milky Way is not transparent. It is filled with stars, dust, gas, and glowing clouds. From Earth, when we look along the flat disk of our galaxy, our view becomes crowded and blocked. This region is called the zone of avoidance. It is one of the most frustrating parts of the sky for astronomers. Not because nothing is there, but because too much of our own galaxy is in the way. Stars crowd the field of view. Dust absorbs light. Distant galaxies behind the Milky Way become hidden, dimmed, or completely invisible in ordinary observations. And behind that curtain, in the direction of the Great Attractor, something enormous was shaping the motion of galaxies. Imagine trying to understand a mountain while standing inside a foggy forest. You can feel the slope beneath your feet. You can see streams flowing in one direction. You can sense that the land is pulling everything downward. But the mountain itself is hidden behind trees and mist. That is what astronomers faced. They could see the motion. They could measure the pull. But the source was obscured. In the 1970s, astronomers began noticing that galaxies were not behaving exactly as expected. The universe is expanding, and on the larger scales, galaxies are carried away from one another by that expansion. But galaxies also have their own motions caused by gravity. These are called peculiar velocities, small deviations from the smooth expansion of the universe. And the peculiar motion of our region was not small. The Milky Way and its neighboring galaxies were moving toward a particular region of space at hundreds of kilometers per second. The motion was too organized to ignore. Something was disturbing the simple expansion, adding an extra pull, creating a flow. It was as if our entire cosmic neighborhood had been caught in a current, a river of galaxies, not water, but stars, not flowing through land, but through space-time. This discovery changed the way astronomers saw the universe around us. The Milky Way was not alone. It was not simply sitting as an island in space. It was part of a much larger structure, a network of galaxies, clusters, superclusters, walls, filaments, and voids. The universe is not evenly scattered. On the larger scales, matter forms a cosmic web. Galaxies gather into groups. Groups gather into clusters. Clusters connect into filaments. Between them are enormous voids, regions with far fewer galaxies, dark and almost empty compared with the bright threads around them. Gravity builds this web slowly. It pulls matter together over billions of years. Dark matter forms hidden scaffolding. Gas follows. Galaxies form along the densest regions. Clusters grow where filaments meet. And our Milky Way is only one galaxy inside that vast structure. When astronomers discovered the Great Attractor, they realized we were not just orbiting inside the Milky Way. Our galaxy itself was falling through the cosmic web, guided by the gravity of structures so large that the human mind almost refuses to hold them. This is the first thing that makes the Great Attractor so haunting. It gives motion to everything we thought was stable. The sun feels like the center of our world. The Milky Way feels like the great home of our stars. But even the Milky Way is being pulled. Everything we know is moving towards something we cannot directly see. Not in the sense of falling into it tomorrow. Not in the sense that Earth will suddenly be dragged away. These motions happen over cosmic time, across distances so vast that they do not affect daily life. No one wakes up because the Great Attractor is pulling. No ocean tide rises because of it. No planet is torn from orbit. But the motion is real. Our galaxy is part of it. And that is enough to make the universe feel different. Because it means that even at the scale of galaxies, there is no final stillness. There is no fixed cosmic center where everything rests. There are only structures pulling on structures, motions layered over motions, invisible mass shaping visible light. The Great Attractor is not a monster in space. It is gravity revealing that we live inside a much larger flow. Still, the mystery remained. What was it? What could pull so many galaxies? At first, it was tempting to imagine one enormous hidden object, a supermassive black hole larger than anything known, a single dark mass sitting behind the Milky Way, a cosmic trap pulling everything inward. But the real answer is more complex and, in some ways, even more impressive. The Great Attractor is not one object. It is a region, a concentration of galaxies and dark matter in the direction of the Hydra-Centaurus region, connected with massive galaxy clusters and larger structures beyond. One of the important structures in that area is the Norma cluster, a rich cluster of galaxies hidden close to the zone of avoidance. It contains a huge amount of matter, visible and invisible, contributing to the gravitational pull that astronomers detected. But even the Norma cluster is not the whole story. As observations improved, scientists realized that the Great Attractor itself may not be the final destination of the flow. Beyond it, even farther away, lies the Shapley Supercluster, one of the most massive concentrations of galaxies in the nearby universe. The Shapley region may contribute strongly to the motion of our local galaxies. So the truth became larger than the original mystery. Our galaxy is not being pulled by one hidden planet, one star, or one black hole. It is being influenced by an enormous landscape of matter. Clusters beyond clusters, superclusters beyond superclusters. A gravitational terrain so vast that galaxies move through it like leaves caught in an invisible river. This is why the Great Attractor remains powerful as an idea, even after scientists learned more about what lies in that direction. The name captures the feeling of discovery, the feeling that something unseen was shaping the motion of everything around us, the feeling that the universe has hidden architecture and that we are not standing outside it, looking in. We are inside it. We are moving with it. From Earth, the Great Attractor is hidden behind the stars and dust of the Milky Way. But its presence was revealed through motion, the same way an unseen planet can be revealed by the wobble of a star, or dark matter can be revealed by the motion of galaxies in a cluster. Astronomy often works this way. We do not always see the thing directly. We see what it does. A black hole is known by the matter swirling around it. Dark matter is known by the gravity it adds. An exoplanet is known by the dimming of a star or the tiny pull it causes. The Great Attractor was known by the motion of galaxies. Something was pulling. The galaxies were answering, and the answer was written in speed. That is what makes gravity so strange. It can reveal what light hides. Dust can block our view. Stars can crowd the sky. But gravity still works through the darkness. It does not need permission from visibility. It acts across space, whether we can see the source or not. The Milky Way blocked the view. Gravity did not care. The galaxies moved anyway. When astronomers mapped more galaxies behind the zone of avoidance using different wavelengths, especially radio and infrared observations that can see through dust better than visible light, the hidden universe began to appear. Galaxies that had been concealed behind our own galaxy slowly entered the map. The cosmic web behind the Milky Way became clearer. It was like lifting a curtain and discovering that the room behind it was filled with cities. The Great Attractor was not an empty mystery. There was structure there, mass, clusters, galaxies, a deeper cosmic arrangement we had been blind to because our own home galaxy stood in the way. There is something poetic about that. The Milky Way, the galaxy that gave birth to our sun, also hides part of the universe from us. Our home protects our view in one direction and blocks it in another. We look outward from inside a glowing disk, trying to understand a cosmic structure far larger than the galaxy that contains us. We are observers inside the thing we are trying to map. That makes astronomy difficult, but also beautiful, because every measurement becomes an act of escape. We build instruments to see beyond dust. We measure redshifts. We map galaxy motions. We compare what we see with what gravity predicts. Slowly, the hidden structure emerges, and then the universe becomes deeper again. The Great Attractor is part of a larger pattern of cosmic flows. Our local group, which includes the Milky Way and Andromeda, is moving not only because of nearby matter, but because of the distribution of mass across a huge region of the universe. There are pulls from dense regions and pushes from voids, places where less matter exists and gravity is weaker. The universe is like a landscape. Dense regions act like valleys, pulling motion toward them. Voids act almost like high ground, not pushing in a true forceful sense, but contributing to motion because there is less gravity pulling from those directions. Galaxies move through this landscape, not freely, not randomly, but guided by the shape of cosmic matter. Our solar system is riding inside the Milky Way. The Milky Way is moving inside the local group. The local group is moving within larger structures, and those structures are part of the cosmic web, layer upon layer of motion, a nested journey through space. You can be sitting still in a chair and still be moving through the universe at enormous speed in several different ways at once. Your body is on Earth. Earth spins. Earth orbits. The sun travels around the Milky Way. The Milky Way moves toward Andromeda. The local group moves within the larger flow. And beyond that, our region of galaxies is affected by massive structures like the Great Attractor and Shapley. Stillness is an illusion created by scale. We feel still because everything near us is moving with us. The room moves with Earth. Earth moves with the sun. The sun moves with the galaxy. The galaxy moves with its group. We do not feel these motions because they are shared, smooth, and enormous. But the universe is carrying us through space every second. This is what the Great Attractor teaches first. We are not fixed. We are falling. Not falling toward destruction, but falling through a gravitational landscape too large to see all at once. The word falling may sound frightening, but in space, falling is motion under gravity. Earth is falling around the sun. The moon is falling around Earth. The sun is falling around the galaxy. The Milky Way is falling through the cosmic web. Falling does not always mean crashing. Sometimes falling is orbit. Sometimes it is flow. Sometimes it is the shape of the universe guiding motion over billions of years. The Great Attractor is part of that flow. But why does it matter to us? It matters because it changes our sense of cosmic address. We used to think of Earth as the center. Then the Sun became the center of our planetary system. Then the Sun became one star in the Milky Way. Then the Milky Way became one galaxy among billions. Then galaxies became part of clusters, superclusters, and filaments. And now, even those structures are not fixed. They move, they stream, they fall toward concentrations of matter and away from emptier regions. Every time humans expand the map, we discover that our home is part of something larger. The Great Attractor was one of those discoveries. It told us that our galaxy is not simply drifting through an expanding universe. It is being shaped by the hidden mass around it. We are part of a cosmic flow that includes thousands of galaxies, all moving through space under the influence of structures too large for the eye to recognize. That is why the discovery shocked astronomers. It revealed motion at a scale that felt almost impossible. Not one planet, not one star, not one galaxy, a whole region of the universe moving together. The idea that thousands of galaxies could share a motion toward an unseen gravitational concentration was profound. It meant the universe was more structured than a simple expansion. It meant that beneath the general stretching of space, gravity was still gathering matter, organizing motion, and building colossal patterns. The expansion of the universe pulls galaxies apart on the larger scales. Gravity pulls matter together on smaller, but still enormous scales. The Great Attractor lives in the tension between these forces. Expansion says everything should separate. Gravity says dense regions should gather. The universe does both. It expands, but it clumps. It stretches, but it forms structure. It grows colder and larger, but within it, matter still finds other matter. That is why galaxies exist at all. That is why clusters exist. That is why the Great Attractor could exist. It is not fighting the universe. It is part of how the universe evolves. And yet, from our human point of view, it feels mysterious because we are being pulled towards something hidden. There is a deep emotional power in that image. Everything we know moving toward a place we cannot see. The sun, Earth, the planets, the stars of the Milky Way, the neighboring galaxies, all part of a motion that began long before life on Earth and will continue long after us. But we should not imagine the solar system being ripped apart. The title says, pulling our solar system apart, and that gives the story its drama. But the Great Attractor is not tearing Earth away from the sun. Its gravitational effect is spread across enormous distances and acts on galaxies as whole systems. The planets remain bound to the sun. The sun remains part of the Milky Way. The Milky Way remains held together by its own gravity. The Great Attractor pulls on the larger stage. It is not breaking the solar system directly. It is carrying the entire galaxy in a larger flow. That distinction makes the truth even more interesting. The solar system is not being locally destroyed. It is being transported, carried inside the Milky Way as the Milky Way moves through a gravitational current, like a ship inside a river, with every object on board still arranged normally, while the entire vessel moves toward a distant bend no one can see. Tonight, we begin by feeling that motion. Not the motion of a planet around the sun, but the motion of galaxies through the invisible architecture of the universe. The Great Attractor is not a hidden planet. It is something far larger, a region of mass so enormous that it helped reveal how galaxies move together across deep space, a clue that our cosmic neighborhood is part of a greater flow, a mystery hidden behind the bright dust and stars of our own galaxy. And although scientists have learned much more about it, the feeling remains. Something is pulling, something vast, something we could not see at first because the Milky Way itself stood in the way. The discovery reminds us that the universe is full of hidden forces. Some hide because they are dark, some hide because they are distant, some hide because our own galaxy blocks them, some hide because they are not single objects, but enormous patterns spread across space. The Great Attractor is one of those patterns. It is not a glowing monster. It is not a cosmic mouth waiting to swallow galaxies. It is a gravitational clue, a sign that matter, both visible and invisible, has gathered in huge amounts beyond the zone of avoidance, shaping the motion of our galaxy and its neighbors. And somewhere tonight, as Earth turns quietly beneath the stars, we are moving with that flow. We do not feel it. We do not hear it. The oceans remain calm. The ground remains steady. The sun will rise again. But on the larger scales, our entire cosmic neighborhood is traveling. The solar system rides with the sun. The sun rides with the Milky Way. The Milky Way rides through the cosmic web, and beyond the stars of our own galaxy, hidden for so long behind dust and light, the Great Attractor waits as one of the first great signs that everything we know is part of a motion far bigger than ourselves. Tonight, we follow that pull, not because it will destroy us tomorrow, not because Earth is in danger from it, but because it reveals something deeper. Our home is moving through an invisible universe, and the more we measure that motion, the more we understand that space is not empty, not still, and not silent. It is filled with gravity, filled with hidden mass, filled with galaxies flowing toward unseen structures. And somewhere beyond the bright veil of the Milky Way, something enormous changed the way we understand our place in the cosmos. Our solar system is not moving the way a simple map of the universe would suggest. If we could rise above the Milky Way and watch everything from the outside, we would not see the sun sitting still with planets calmly circling around it. We would see a system in motion, Earth moving around the sun moving around the Milky Way moving with the local group, and beyond that, our entire cosmic neighborhood drifting through space with a speed and direction that once seemed deeply strange. This motion is not random, it has a pattern, and that pattern is the evidence we cannot ignore. The sun, Earth, and everything near us are moving through the universe at hundreds of kilometers per second. Not because of one planet, not because of one star, not because of anything inside the solar system. The cause is much larger than that. Our region of space is flowing toward the direction of Centaurus, around 600 kilometers per second. That number is almost impossible to feel from Earth. We do not sense it. We do not wake up and feel the planet rushing through the universe. The ground does not shake. The stars do not streak across the sky. The oceans do not lean towards Centaurus. Everything around us shares the same motion. So to us, it feels like stillness. But stillness is only a local illusion. On the larger scales, we are moving fast, very fast. 600 kilometers per second means that in 1 second, our cosmic neighborhood travels farther than most people will travel in an entire day. In 1 minute, it moves tens of thousands of kilometers. In 1 hour, more than 2 million kilometers. And it has been doing this not for a day or a year or a century, but across cosmic time. The question is simple. Why? Why is the Milky Way moving this way? Why are nearby galaxies sharing similar motions? Why does the local group, the family of galaxies that includes the Milky Way, Andromeda, and smaller companions, appear to be caught in a larger gravitational stream? At first, astronomers expected the universe to expand. On the larger scales, galaxies move away from one another because space itself is stretching. The farther away a galaxy is, the faster it generally appears to recede from us. This expansion is one of the foundation stones of modern cosmology. But real galaxies do not move only with the expansion. They also respond to gravity. If there is a large concentration of mass somewhere, galaxies can be pulled toward it. Their motion can deviate from the smooth flow of expansion. These extra motions are called peculiar velocities. The word peculiar sounds almost gentle, but what it revealed was enormous. The peculiar velocity of our cosmic neighborhood showed that something was influencing us. The Milky Way was not simply moving with the general expansion of the universe. It had an extra motion, a drift through space toward a region where something massive must exist. And this was not only happening to us. Other galaxies nearby showed similar motion. The local group itself seemed to be part of a larger flow. Galaxy after galaxy, group after group, cluster after cluster, all moving in a direction that suggested an unseen gravitational source. It was as if the universe had a current, and our galaxy was caught inside it. This is one of the most important pieces of evidence for the Great Attractor. We did not discover it first by taking a beautiful image of something enormous. We discovered it through motion. Astronomers measured galaxy speeds. They compared those speeds with the expansion of the universe. They noticed the deviations, and the deviations pointed toward a hidden mass. Something was pulling, not with a rope, not with light, not with any visible force, only gravity. But gravity is enough. Gravity is the oldest language of the universe. It does not need to shine. It does not need to announce itself. It can reveal invisible matter through the motion of visible objects. If stars move strangely, something may be pulling them. Galaxies orbit too fast. Dark matter may be present. If clusters move together, a larger structure may be guiding them. The Great Attractor was not seen first. It was felt mathematically. The galaxies were moving as if the universe ahead of us was heavier than it looked. And when scientists calculated how much mass would be needed to explain that motion, the answer was staggering. It would require a concentration of matter far beyond the scale of a normal galaxy. Not millions of stars, not billions, but enough mass to influence thousands of galaxies across a vast region of space, tens of thousands of times the mass of the Milky Way. That phrase is hard to absorb because the Milky Way itself is already enormous. Our galaxy contains hundreds of billions of stars. It contains nebulae, star clusters, black holes, dark matter, dust, gas, and worlds beyond counting. The Sun is only one star inside it. Earth is only one planet around that one star. And yet, the motion of galaxies suggested something with a mass equivalent to many thousands of Milky Ways was influencing our region, not in one compact object, not as a single monster black hole, but as a vast concentration of galaxies, galaxy clusters, gas, and dark matter, a gravitational landscape so large that our galaxy was only one small participant in the flow. This is the scale where human intuition begins to fail. A planet pulls on moons, a star pulls on planets, a galaxy pulls on stars. But here we are talking about structures pulling on galaxies, entire galaxies becoming the moving pieces. The Milky Way, with all its stars, worlds, and history, becomes like a leaf in a current, and the current points toward a region we could not clearly see. That was the next problem. The evidence said something massive was there, but when astronomers looked in that direction, the view was blocked. The Great Attractor lies behind the plane of our own galaxy, in a region known as the zone of avoidance. This is the part of the sky where the disk of the Milky Way gets in the way of looking beyond it. From our position inside the galaxy, we look through clouds of stars, dust, and gas. The view becomes crowded and obscured. The Milky Way is beautiful, but it is also a curtain. Its dust absorbs visible light. Its stars fill the foreground. Distant galaxies behind it become difficult or impossible to see with ordinary telescopes. It is like trying to study a city beyond a mountain range while standing in the middle of a storm. You know something is there because the landscape around you is affected, but you cannot see it clearly. That is what made the Great Attractor so mysterious. The motion was undeniable. The mass was required, but the region itself was hidden. Astronomers were trying to solve a cosmic mystery while our own galaxy blocked the crime scene. So they turned to other kinds of light. Visible light struggles to pass through the dusty plane of the Milky Way, but not all wavelengths are blocked equally. Radio waves can pass through dust more easily. Infrared light can reveal hidden structures behind clouds. X-ray telescopes can detect hot gas in galaxy clusters because clusters often contain enormous amounts of heated material glowing at high energies. Slowly, by looking beyond visible light, astronomers began to penetrate the zone of avoidance, and what they found was not emptiness. There were galaxies, clusters, hidden structures, matter where matter was expected. One of the most important discoveries in that region was the Norma cluster, a rich galaxy cluster located near the direction of the Great Attractor. It contains a huge concentration of galaxies and hot gas, and it became a major candidate for part of the hidden mass pulling on our local universe. This was a breakthrough. The hidden region was not just a blank patch of sky. It contained real structure, a massive cluster buried behind the Milky Way's dust, exactly where the motion of galaxies suggested something important should be. For a moment, it seemed like the mystery might be solved. But the deeper astronomers looked, the more complicated the answer became. The Norma cluster was massive, but it was not enough by itself. The Great Attractor was not simply one cluster hiding behind the Milky Way. It was part of a larger gravitational pattern. More observations showed that even beyond the Great Attractor region, farther away, there was another enormous structure, the Shapley Supercluster. This is one of the richest concentrations of galaxies in the nearby universe. It is so massive that it contributes strongly to the motion of galaxies across a huge cosmic volume. And suddenly, the mystery grew larger. Maybe the Great Attractor was not the final destination. Maybe it was only one part of a larger pull. Maybe our cosmic neighborhood was moving not toward one hidden object, but through a gravitational landscape shaped by several massive structures, including the Great Attractor. the Norma cluster, and the Shapley Supercluster beyond. This is why the evidence raised more questions than answers. The first mystery was simple. Something is pulling us. The next mystery was harder. What combination of hidden mass, visible clusters, dark matter, and larger superstructures explains the motion? The universe was not giving a single, clear answer. It was giving layers. That is often what happens in astronomy. A mystery begins with one strange observation. Scientists imagine one cause. Then better data arrives, and the cause becomes more complex. What looked like one object becomes a region. What looked like one region becomes part of a larger structure. What looked like a destination becomes one valley inside a much larger gravitational landscape. The Great Attractor was not a simple monster. It was a signpost, a clue pointing toward the cosmic web. To understand the motion, we have to understand that galaxies are not scattered evenly across space. They form filaments, walls, clusters, and superclusters, separated by enormous voids. Matter gathers where gravity has had time to work. Dark matter forms invisible scaffolding. Normal matter follows. Galaxies grow along the densest lines. Our Milky Way belongs to this web. More specifically, we are part of a much larger structure called Laniakea. Laniakea is sometimes described as our supercluster, our larger cosmic address. The name means immense heaven, and it is fitting because it contains around 100,000 galaxies spread across a staggering region of space. The Milky Way is only one galaxy inside it, a small member of a vast flow. In Laniakea, galaxies are not simply sitting in place. They move along gravitational paths. Their motions can be mapped like streams flowing through a landscape. When astronomers studied these flows, they found that galaxies in our region appear to move inward toward a gravitational basin. The Great Attractor lies near the heart of this flow, though the larger picture includes structures beyond it. This gives us a new way to imagine the universe, not as static dots on a black background, but as currents, galaxies flowing through space like water through valleys. The Milky Way is not outside this flow, it is inside it. And because we live inside the Milky Way, everything we know is carried with it. Earth, the Sun, every planet, every asteroid, every spacecraft, every human memory, all moving within a galaxy that is itself moving through the cosmic web. That is the evidence we cannot ignore. Motion on a scale so large that the entire Milky Way becomes part of a river. This motion is not something we can feel, but it can be measured. Astronomers use redshifts, distances, galaxy surveys, cosmic microwave background measurements, and velocity maps to understand how galaxies move relative to the expansion of the universe. The cosmic microwave background is especially important. It is the ancient afterglow of the early universe, radiation left over from a time when the universe was young and hot. It fills all of space. Against this background, our motion creates a dipole pattern, a slight difference in temperature between the direction we are moving toward and the direction we are moving away from. It is like feeling a cosmic wind, not a wind of air, but a pattern in ancient light. From this, scientists can measure how fast our local region moves relative to the early universe's background radiation. That motion is part of the evidence that the Milky Way is moving at hundreds of kilometers per second through space. Again, the universe is telling us through a subtle signal, a temperature difference in ancient radiation, a pattern of galaxy velocities, a hidden cluster behind dust, a supercluster beyond the first mystery. Evidence from different directions begins to point toward the same truth. We are moving through a gravitationally uneven universe. Mass is not spread perfectly. Dense regions pull. Voids leave less pull behind them. Galaxies flow along the cosmic web, and our galaxy is part of that flow. One of the most haunting things about this discovery is that the source of the pull was not obvious from the sky. If you look toward the constellation Centaurus with your eyes, you do not see a giant glowing object dragging the Milky Way. You do not see a cosmic whirlpool. You do not see a black hole swallowing galaxies. You see stars. You see the Milky Way's own foreground. You see the local veil, not the deeper structure behind it. The evidence is hidden in measurement. This is why astronomy often feels like learning to see the invisible. The eye says the sky is quiet. The data says everything is moving. The eye sees stars. The data reveals mass behind them. The eye sees darkness. The data reveals flow. The Great Attractor is powerful not because it looks dramatic, but because it shows how much of reality exists beyond appearance. If we judge the universe only by what we could see directly, we would miss the deepest structure. We would miss dark matter. We would miss black holes before they feed. We would miss exoplanets around distant stars. We would miss the Great Attractor hidden behind the Milky Way. Science begins where ordinary vision ends. And in this case, ordinary vision failed because our galaxy itself was in the way. The zone of avoidance is a reminder that we are not observing the universe from a perfect position. We are not floating outside all galaxies with a clean view in every direction. We are embedded inside a disk of stars and dust. Our view is shaped by our location. Some parts of the universe are easy to study. Others are hidden behind the structure we call home. That makes the discovery even more impressive. Astronomers had to infer the hidden universe from motion. Then they had to use different wavelengths to peer through the dust. Then they had to map galaxies beyond the zone. Then they had to build larger models to explain why the motion remained only partially accounted for. The Shapley Supercluster became crucial because the Great Attractor alone was not enough. It helped explain the flow, but not completely. Shapley, farther away and even more massive, adds another layer of gravitational influence. Together, these structures show that our motion is not caused by a single pull, but by the combined gravity of massive concentrations in the cosmic web. This is more realistic and more humbling because it means our galaxy's path is shaped by structures far beyond what the first mystery suggested. We are not falling toward one simple object. We are moving through a vast gravitational terrain with multiple influences where nearby and distant structures combine to guide the flow of galaxies. Imagine standing in a valley. A nearby hill affects how water flows around your feet. A larger mountain range farther away affects the whole river system. The final direction of the current depends on the entire landscape, not just one slope. That is how cosmic motion works. The Great Attractor is part of the slope. The Shapley Supercluster is another. Voids and underdense regions also matter. The final motion of the Milky Way is the result of the whole landscape of matter around us. And because much of that matter is dark matter, we are again dealing with something invisible. Galaxies and gas are only the luminous part of the story. Dark matter, which does not emit or absorb light, makes up much of the mass that shapes cosmic structure. It forms the gravitational scaffolding where galaxies gather. It deepens the valleys of the cosmic web. It adds mass to clusters and superclusters. The Great Attractor is not only visible galaxies pulling on us, it includes invisible mass, dark matter, the hidden weight of the universe. This is why the required mass sounds so incomprehensible. The visible galaxies are impressive, but they are not all. The gravity comes from everything: stars, gas, dust, hot plasma, galaxies, and dark matter. Most of the mass may be something we cannot see directly. The universe pulls with darkness, and the galaxies obey. This should make us careful with the phrase hidden planet. In this chapter, the hidden thing is not a planet like Earth or Neptune. It is far larger. It is a hidden concentration of cosmic structure. The title is dramatic, but the reality is more astonishing. Not one planet pulling our solar system, but an entire region of the universe pulling the galaxy that carries us. The solar system is not being torn apart locally. It is being carried. The sun still holds the planets. Earth still orbits safely. The moon still circles Earth. But all of this is happening inside a galaxy that is moving through space toward a larger gravitational basin. The pull is not felt as danger. It is felt as cosmic direction. The evidence tells us that our place in the universe is dynamic. Our galaxy is not a fixed island. It is moving with others, guided by mass hidden partly behind our own galaxy and partly in deeper structures beyond. And the more we look, the less isolated we become. The Milky Way is part of the local group. The local group is part of Laniakea. Laniakea is influenced by the Great Attractor region. The Great Attractor is part of a larger flow involving the Shapley Supercluster and the surrounding cosmic web. Every address leads to a larger address. Every motion leads to a larger motion. This is what makes the evidence impossible to ignore. It comes from too many directions: galaxy velocities, cosmic microwave background measurements, hidden clusters revealed through X-ray and radio observations, large-scale maps of galaxy flows, the structure of Laniakea, the mass of Shapley, the obscuring veil of the zone of avoidance. Together, they tell one story. Something massive is shaping our motion, not in the future, not hypothetically, right now. As Earth rotates tonight, as the sun carries us around the Milky Way, as the Milky Way moves through space, we are part of a flow measured in hundreds of kilometers per second. We do not feel it because we are inside it. Like passengers asleep on a ship crossing a dark ocean, we move without sensing the current beneath us. But the instruments sense it. The equations reveal it. The galaxies show it. And the more carefully we measure the universe, the more clearly the motion appears. This is the quiet power of the Great Attractor mystery. It is not loud. It is not visible in a single image. It does not announce itself with fire or light. It exists in the difference between where galaxies should be moving and where they actually move. A difference of speed, a direction in space, a pull behind a curtain of dust, a concentration of mass too large to ignore. And this is why the evidence feels almost unsettling, because it means the universe is not only expanding away from us, it is also pulling us into structure. We are not merely watching the cosmos from a safe distance. We are inside the machinery, inside the flow, inside the cosmic web. And somewhere beyond the crowded plain of the Milky Way, beyond the zone of avoidance, beyond the regions our eyes cannot easily reach, immense concentrations of matter continue to shape the path of our galaxy. The Great Attractor was the first name we gave to that hidden pull. Shapley made the story larger. Laniakea gave us the map. And the motion of our own solar system gives us the evidence. Something is pulling. Not just us. Not just the sun. Not just the Milky Way. A whole river of galaxies is moving through the dark. And tonight, we are moving with it. So what is actually pulling us? That is the question at the center of this mystery. Not what direction are we moving. Astronomers can measure that. Not whether the motion is real. The evidence is too strong to ignore. The deeper question is what kind of structure in the universe could be powerful enough to influence the motion of entire galaxies. Because this is not a small pull. This is not the gravity of one star, not one black hole, not one galaxy hiding behind the Milky Way. The motion of our cosmic neighborhood requires something larger than almost anything our minds are used to imagining. For a long time, the Great Attractor sounded like a single object. The name almost invites that image, a hidden thing in space, a dark gravitational monster, a massive, invisible body pulling galaxies toward itself like a cosmic drain. It is easy to imagine something sitting behind the Milky Way, waiting in darkness, dragging everything toward it. But the universe is rarely that simple. The Great Attractor is not one object. It is not one planet. It is not one star. It is not one black hole. It is not even one galaxy. It is a vast region of mass, a gravitational landscape made of galaxy clusters, gas, dark matter, filaments, and the larger structure of the cosmic web. It is not a single point pulling us in the way Earth pulls the moon. It is more like a valley in the shape of space, a huge region where matter has gathered so deeply that galaxies flowed toward it over hundreds of millions of years. And even that is only part of the story, because when astronomers looked farther, beyond the original direction of the Great Attractor, they found something even larger, the Shapley Supercluster, a colossal concentration of galaxies about 200 million light-years away, one of the most massive structures in the nearby universe, a region so dense with galaxies and dark matter that it helps shape the motion of galaxies across an enormous volume of space. If the Great Attractor was the first mystery, Shapley made the mystery bigger. It showed that we were not being pulled by one hidden thing alone. We were being influenced by a chain of structures, one beyond another, each adding its gravity to the flow. The Shapley Supercluster contains thousands of galaxies, not stars, galaxies. Each galaxy may contain billions or hundreds of billions of stars. Each may carry planets, dust, gas, black holes, and dark matter halos. And all of these galaxies together form a mass concentration beyond ordinary imagination. To understand its scale, think of the Milky Way. Our galaxy already feels infinite to us. It contains the sun, all the visible stars of our night sky, star-forming nebulae, ancient clusters, black holes, dust lanes, and billions of possible worlds. It is so large that light takes about 100,000 years to cross it. Now imagine thousands of galaxies gathered into one immense region, not packed tightly like stars in a cluster, but spread across a huge cosmic volume, bound into the larger architecture of the universe. That is the kind of structure we are dealing with. The Shapley Supercluster is not a place you can picture like a planet or a nebula. It is too large for that. It is a continent of galaxies in the cosmic web, a gravitational province, a deep mass concentration in the universe's larger landscape, and it matters because it appears to account for a major part of the motion of our local group, perhaps around half of our peculiar velocity. That means the Shapley region is one of the major reasons our cosmic neighborhood is moving the way it is. The Milky Way, Andromeda, and the smaller galaxies around us are not simply drifting randomly. They are participating in a flow shaped partly by this enormous distant concentration. But Shapley does not explain everything by itself. That is the haunting part. Even with the Shapley Supercluster, even with the Great Attractor region, even with the clusters hidden behind the Milky Way, the full motion of our cosmic neighborhood is not explained by one simple pull. The universe is more complicated than that. Our trajectory is shaped by several forces at once, some pulling, some in a different way, pushing. This is where the story becomes even stranger, because we are not only being pulled toward regions where matter is dense, we are also moving away from regions where matter is missing. This idea sounds strange at first. How can empty space push anything? A void does not push like a hand. It does not emit force like an engine. But in gravity, direction depends on the whole landscape of mass around you. If one side of the universe contains a massive concentration of galaxies, it pulls. If the opposite side contains a giant underdense region, a void with much less matter than average, then there is less gravity pulling from that direction. The result feels like a push, not because the void is actively shoving us, but because the pull from the other side is stronger. Imagine floating in a dark ocean with currents. On one side, water is flowing strongly toward a deep basin. On the other side, there is less resistance, less pull, less matter holding you back. You move away from the emptier region and toward the denser one. The universe works something like that on huge scales. Dense regions act like attractors. Voids act like repellers. And in 2017, scientists identified something called the dipole repeller, a vast underdense region on the opposite side of our motion, helping explain why our galaxy is moving the way it does. The name is powerful because it changes the picture completely. We are not simply falling toward a hidden mass. We are also moving away from a cosmic emptiness, pulled from one side, released from the other. The motion of the Milky Way becomes the result of both. The Great Attractor and Shapley pull us toward dense cosmic structure. The dipole repeller helps push us away from an emptier region. Together, they shape our current trajectory through the universe. This is one of the most beautiful ideas in modern cosmology. Our galaxy is moving through a landscape of gravity where both matter and absence of matter matter. The universe is not a flat, empty stage. It has hills and valleys. The valleys are dense regions full of galaxies and dark matter. The high places are voids, enormous regions where far fewer galaxies exist. Galaxies flow down the gravitational landscape, away from emptiness and toward mass. And the Milky Way is one of those galaxies. This means the thing pulling us is not one hidden object. It is the structure of the universe itself, a cosmic web of filaments, clusters, superclusters, and voids. The Great Attractor is one convergence point in that web. Shapley is another major concentration beyond it. The dipole repeller is part of the emptier side of the landscape, and dark matter forms the hidden skeleton beneath it all. Without dark matter, none of this makes sense. The visible galaxies are only part of the mass. We can see stars, we can detect hot gas, we can map clusters, But much of the gravity comes from matter we do not see directly. Dark matter does not shine. It does not reflect light. It does not form stars. But its gravity is real. It shapes galaxies. It holds clusters together. It guides the formation of the cosmic web. It deepens the gravitational wells toward which galaxies flow. The Great Attractor is not only a collection of visible galaxies, it is also a concentration of dark matter, invisible but dominant, helping create the gravitational pull we measure. This is where the mystery becomes deeper than any single region. The universe we see is only the bright surface. The deeper mass is hidden. Every galaxy sits inside a halo of dark matter. Clusters contain huge dark matter components. Filaments of the cosmic web are shaped by dark matter, stretching across space. When we say galaxies are flowing toward the Great Attractor, we are really saying they are responding to the full gravitational field. Visible matter plus invisible matter. Ordinary atoms plus dark matter. The universe pulls with both light and darkness, and we are moving through that pull. This is why the Great Attractor feels so mysterious, even when we know more than before. It is not mysterious because there is no explanation. It is mysterious because the explanation is larger than the name. The name sounds like a thing. The reality is a system, a vast arrangement of mass, a flow of galaxies, a hidden dark matter skeleton, a cosmic geography of dense regions and voids, a motion created by pull and repulsion at the same time. When astronomers first discovered the motion towards Centaurus, it was natural to imagine a source, something in that direction, something hidden behind the zone of avoidance, something massive enough to pull on the Milky Way. And that was partly true. There were hidden clusters there. The Norma cluster and surrounding structures were real. They contributed to the attraction. They helped explain why galaxies were flowing in that direction. But as the map expanded, the flow did not stop at the Great Attractor. It pointed beyond. The Shapley Supercluster entered the story as an even larger mass concentration farther away. It became clear that our motion could not be explained only by the local hidden structures. The Great Attractor was not the final answer. It was one important region inside a larger gravitational current. That is how cosmic discovery often works. The first answer opens the next question. We find a hidden mass. Then we find a larger structure behind it. Then we discover that even the larger structure is part of a web. Then we realize the web itself is shaped by dark matter and cosmic expansion. The universe keeps expanding the mystery, not because science fails, but because each layer reveals a larger one. The Shapley Supercluster is a perfect example. At around 200 million light-years away, it is far beyond the scale of ordinary imagination. The light we see from that region began its journey long before modern humans existed. When that light left Shapley, Earth was ruled by ancient life forms that have long vanished. The continents were arranged differently. The planet's surface was another world, and yet that structure is part of our present motion. Its gravity, along with other structures, helps shape the path of our galaxy. This is one of the strange things about gravity and distance. Gravity does not need something to be nearby to matter if the mass is large enough. Shapley is enormously far away, but it is also enormously massive. Its influence becomes part of the cosmic flow. The Milky Way is not falling into Shapley like a stone falling to Earth. The expansion of the universe complicates everything. These structures are not simple destinations in the ordinary sense. Space is expanding, and gravitational flows are layered on top of that expansion. But the direction of our motion still carries the imprint of these mass concentrations. We are being guided by the distribution of matter across a huge region of the universe. That phrase sounds abstract, but it means something simple. Where matter gathers, galaxies move. Where matter is missing, galaxies move away. Our galaxy is moving because the universe around us is uneven. If matter was spread perfectly equally in all directions, there would be no special pull. The expansion would dominate smoothly. But matter is not equal. It clumps, it forms clusters, it leaves voids. Gravity amplifies small differences over billions of years until the universe becomes a web. We live inside that web. And the Great Attractor is one of the names we gave to a place where the web pulls inward. But then there is the cold spot. The cold spot is a strange feature in the cosmic microwave background, a region of the ancient radiation of the universe that appears slightly cooler than expected. It has been discussed for years, and some have wondered whether it connects to unusual, large-scale structures, perhaps an enormous void, perhaps something more complicated in the distribution of matter. Could it be related to the Great Attractor? The answer is uncertain. It is tempting to connect every large cosmic mystery to every other one. A hidden attractor here, a cold region in ancient light there, a massive void somewhere else. But the universe is full of large structures, and not every mystery belongs to the same story. The cold spot remains debated. It may be a statistical feature. It may be related to a large, underdense region. It may have explanations that do not require anything exotic. But it belongs to the same emotional landscape as the Great Attractor. The feeling that the universe has vast hidden structures that only reveal themselves through subtle evidence. A temperature difference, a galaxy velocity, a gravitational flow, a missing mass, a void, a repeller, a supercluster. All of these are clues that the cosmos is not smooth in the way our simplest pictures once imagined. The dipole repeller, however, is more directly connected to our motion. It tells us that the local group's velocity cannot be understood only by asking what lies ahead. We must also ask what lies behind. If behind us is a region with less matter than average, then the gravitational balance pushes our motion away from it. Combine that with the pull from dense structures ahead, and you get a stronger, clearer explanation for our trajectory. We are not being pulled through the universe like an object tied to one rope. We are being shaped by an entire field, a push from emptiness, a pull from mass, a flow through the web. This makes the Great Attractor less like a monster and more like a coordinate in a cosmic river system. Galaxies flow along filaments, clusters form at intersections, voids expand between them. Our Milky Way is moving through one of these streams, and the direction of that stream is determined by both what is there and what is missing. There is a calm terror in that idea. Even absence has a role. The empty regions of the universe help decide where galaxies go. The places with almost nothing still shape the motion of everything, not through force in the ordinary sense, but through the imbalance of gravity. This is why the universe is so hard to visualize. It is not only made of visible lights, it is made of relationships, densities, motions, fields, distances, curvatures, missing matter in one direction and concentrated matter in another. The truth is not a picture. It is a map of motion. And that map tells us that our solar system is part of a huge journey. The Sun is not choosing that journey. Earth is not choosing it. The Milky Way is not choosing it. Everything is simply obeying the gravity of the cosmic web. We are moving toward a region associated with the Great Attractor and Shapley. We are moving away from the dipole repeller. We are flowing with Laniakea. We are carried by the invisible shape of matter. That's what is actually pulling us. Not a hidden planet, not a single dark object, but the large-scale structure of the universe itself. This may seem less dramatic at first than imagining one mysterious body pulling everything apart. But it is actually more astonishing. A single hidden object would be strange. A whole cosmic structure influencing thousands of galaxies is far greater. The Milky Way is not being dragged by a monster. It is moving through a continent of gravity. And this continent is made of ordinary matter and dark matter together. Ordinary matter gives us stars, galaxies, gas, and light. Dark matter gives the structure its deeper gravitational weight. Together, they form the attractors, filaments, and clusters that guide motion on the largest scales. The Great Attractor is one of those regions where the flow converges. A gravitational basin, a place in the cosmic web where galaxies move inward, not because they are doomed, but because mass has gathered there over billions of years. The word attractor is mathematical as much as poetic. It describes motion toward a region in a field. It does not mean everything will be swallowed by a single object. It means the flow of galaxies points that way, shaped by gravity. And the more we learn, the more we see that even this flow is part of something larger. The Great Attractor lies within Laniakea, our vast supercluster. But Laniakea itself is not the final cosmic structure. Beyond it are other superclusters, walls, voids, and filaments. The Shapley Supercluster exerts influence from farther away. The cosmic web continues outward, larger and larger, until the scale becomes difficult to speak about. Every time we think we have found the structure that explains our motion, a larger structure appears. That is the universe's habit. It makes every answer a doorway. The Great Attractor told us we were moving toward hidden mass. Shapley told us the hidden mass was not enough. The dipole repeller told us emptiness matters too. Dark matter told us the visible universe is only part of the story. The cosmic web told us that galaxies are not isolated islands, but beads on invisible threads. And our own motion tells us that we are not outside the story. We are inside it. Every second, Earth moves with the Sun. The Sun moves with the Milky Way. The Milky Way moves through a larger flow. That larger flow is guided by the pull of superclusters and the relative push of voids. The motion is so vast and smooth that we feel nothing, but it is real. We are traveling through an invisible architecture. If you could zoom out far enough, beyond the stars, beyond the Milky Way, beyond the local group, you might see galaxies drifting not randomly, but along pathways. You would see clusters forming knots, filaments stretching like glowing threads, voids opening like dark oceans between them. And in one part of this network, you would see the region we call Laniakea, with flows moving inward toward the Great Attractor region. Somewhere in that map is the Milky Way. Inside the Milky Way is the Sun. Around the Sun is Earth. And on Earth, someone looks up at the night sky and asks why everything is moving. That is the scale of the question, and the answer is larger than fear. It is not that something is pulling our solar system apart. in the way a local disaster would. Earth is safe in its orbit. The planets remain bound. The sun's gravity rules our small neighborhood. But on a larger scale, everything we know is part of a cosmic migration, a slow fall through the web, a motion guided by structures we are only beginning to map. The Great Attractor is not coming for us. We are already in its flow. That is the difference. It is not a future threat. It is a present reality. We have always been moving through this gravitational landscape. Long before humans existed, the Milky Way was part of this motion. Long before Earth formed, the seeds of the cosmic web were already growing from tiny density differences in the early universe. Gravity had been working since near the beginning, pulling matter into patterns that would one day become galaxies, clusters, and superclusters. The motion we measure now is ancient. It began before our galaxy had its current shape, before the sun existed, before Earth, before life. We are latecomers inside a movement that began almost with the universe itself. And yet, we can understand it. That is the most remarkable part. From one planet inside one galaxy, looking through dust, dealing with blocked views, incomplete maps, invisible matter, and enormous distances, humans have still managed to trace the flow. We have measured velocities, mapped clusters, detected hidden galaxies, identified underdense regions, named superclusters, built models of motion across hundreds of millions of light years. The universe is vast, but not completely unreadable. Its motion leaves clues, and when we follow those clues, we discover that what is pulling us is not a monster in the dark. It is the universe's own structure, the Shapley Supercluster ahead, the Great Attractor region closer in the flow, the dipole repeller behind, dark matter everywhere, giving weight to the web, filaments guiding galaxies, voids shaping absence. Together, they create the path of the Milky Way. Together, they carry our cosmic neighborhood through space. And somewhere within that enormous movement, the solar system continues its quiet local dance. The planets circle the sun. Earth turns, night falls, stars rise, everything feels still. But far beyond what we can feel, our galaxy is moving through a vast gravitational current, pulled by mass, pushed by emptiness, and guided by the hidden architecture of the cosmos. That is what is actually pulling us. Not one thing, everything around us, the structure of the universe itself. The strangest part of the Great Attractor is that we are moving toward it, but we may never truly arrive. That sounds impossible at first. If something is pulling us, then surely, given enough time, we should reach it. A stone falls toward Earth. The moon falls around Earth. Planets fall around the sun. Gravity pulls and motion follows. So if the Milky Way is flowing toward a vast region of mass in deep space, it feels natural to imagine that one day, in the far future, our galaxy will reach the center of that pull. But the universe is not that simple. The Great Attractor lies roughly 250 million light-years away. That distance is already beyond ordinary imagination. Light itself, the fastest thing in the universe, would need hundreds of millions of years to cross it. And even though our cosmic neighborhood is moving incredibly fast, around hundreds of kilometers per second, that speed is small compared with the distance involved. At our current motion, we are not traveling toward the Great Attractor like a spacecraft toward a planet. We are not on a direct road. We are not falling through empty space toward a final impact point. We are part of a much larger gravitational flow, carried by the Milky Way, the local group, and the vast structure of galaxies around us. And while gravity is pulling, the universe itself is expanding. That changes everything. Space is not a fixed stage where galaxies simply move from one place to another. Space itself stretches. On the larger scales, distant galaxies move away from each other because the fabric of the universe is expanding. This expansion does not tear apart objects that are strongly bound by gravity. It does not pull Earth away from the Sun. It does not rip stars out of the Milky Way. It does not break apart the local group. But between huge structures separated by hundreds of millions of light years, expansion matters. It competes with gravity. And in the long future, expansion wins more and more. This is why the Great Attractor is not a destination in the normal sense. It is not like a planet we are traveling toward. It is not like a black hole that will eventually swallow everything in its path. It is a region of mass within the cosmic web, a gravitational valley that helps shape the motion of galaxies around it. We are moving in its direction, but the space between us and that region is also part of an expanding universe. The Great Attractor itself is not standing still either. It is part of a larger flow. It is connected to other structures. It is influenced by the Shapley Supercluster and by the surrounding cosmic web. It moves within the universe's larger pattern, just as we do. There is no fixed center waiting there while everything else falls toward it. There are only galaxies, clusters, filaments, voids, dark matter, and expansion all interacting at once. That is the first lesson. Nothing is stationary. Not Earth, not the Sun, not the Milky Way, not the Great Attractor. Everything is moving through something larger. The Great Attractor may sound like a final point, but it is more like one node in a cosmic network. Around it are other nodes, other clusters, other concentrations of matter. Between them stretch filaments of galaxies, like threads in a web. Between those filaments are voids, immense dark regions where fewer galaxies exist. Our galaxy is not falling through empty space toward one object. It is drifting through a gravitational landscape, a landscape with slopes in many directions. The Great Attractor pulls from one direction. The Shapley Supercluster contributes from farther beyond. Other mass concentrations add their influence. Voids with less matter shape the motion from the opposite side. The result is not a straight fall, but a trajectory created by many pulls and absences at once. Imagine a leaf floating in a river. The leaf moves downstream, but not because one point alone is pulling it. The whole shape of the river matters. The banks, the current, the depth, the stones below the surface, the pressure of water behind it, the bends ahead. The leaf is moving towards something, but its path belongs to the entire river. Our galaxy is like that. The river is the cosmic web, and the Great Attractor is only part of the current. If we ask, will we ever get there? The honest answer is probably not in any meaningful sense. Not because the pull is fake. The pull is real. Not because the motion is small. The motion is enormous. But because the universe is expanding, and because the Great Attractor is part of a larger structure that is itself moving within the cosmic flow. The future of the universe is not a simple collapse toward one hidden point. It is a long stretching, a spreading, a gradual separation of structures that are not strongly bound together. On smaller scales, gravity still wins. The Milky Way and Andromeda are moving toward each other. In billions of years, they will merge into a larger galaxy. That event is much closer, much more certain, and much more meaningful to our local cosmic future than reaching the Great Attractor. The stars inside the Milky Way are bound by gravity. The planets are bound to the Sun. The Moon is bound to Earth. The local group is bound together. But beyond that, at the scale of superclusters, the expansion of the universe becomes more important. Structures that once seemed connected by motion may not remain gravitationally bound forever. The cosmic web is real, but the expansion stretches the distances between its largest regions. This means our ultimate future is not to fall into the Great Attractor like a stone into a well. Our future is to remain part of our local gravitational island, while the distant universe slowly recedes. That is a strange and lonely thought. Today, we can map huge structures. We can see galaxies far beyond the local group. We can measure superclusters, filaments, voids, and flows. We can speak about the Great Attractor, Shapley, Laniakea, and the cosmic web. But in the far future, much of that larger universe will become harder and harder to see. As space expands, distant galaxies will move farther away. Their light will stretch. Their signals will fade. Eventually, civilizations in the very far future may look out and see only the galaxies bound to their own local group. The larger cosmic web may disappear beyond their observable horizon. The universe will still be there, but it will be hidden by expansion. In that far future, the Great Attractor may no longer be a meaningful landmark for anyone inside our merged galaxy. The great flows we measure now may become part of ancient astronomy, a chapter in a cosmic history that future observers may struggle to reconstruct. That makes our moment special. We live at a time when the universe is old enough to have formed galaxies, stars, planets, and life, but still young enough that the large-scale structure is visible to us. We can still see distant galaxies. We can still map the cosmic web. We can still detect the motion of our galaxy through space and compare it to the background radiation of the early universe. We are here during a window when the universe can still tell us where we are going. But where are we going? Not to a final destination, not to a cosmic wall, not to a hidden planet, not to a single dark object waiting to swallow the solar system. We are moving through a universe where everything is falling towards something, while everything is also being carried by expansion. The Earth falls around the Sun. The Sun falls around the center of the Milky Way. The Milky Way falls toward Andromeda. The local group moves within a larger flow. That flow is shaped by the Great Attractor, by Shapley, by voids, by dark matter, by the uneven structure of the universe. And beyond all of it, space itself expands, layer upon layer, motion inside motion, fall inside expansion. There is no absolute still point. That is one of the deepest lessons of cosmology. For most of human history, we wanted a center. We wanted Earth to be still. Then we learned Earth moved around the Sun. Then we learned the Sun moved inside the Milky Way. Then we learned the Milky Way was only one galaxy among billions. Then we learned galaxies themselves move in vast streams through the cosmic web. Every time we tried to find stillness, the universe removed it. There is no throne at the center, no fixed floor, no final place where everything rests. There is only motion. Even the Great Attractor, with all its dramatic mystery, is not still. It is part of a larger pattern. It belongs to the same expanding universe we do. It may pull, but it is also carried. It may shape the movement of galaxies, but it is not outside the movement. This is why asking whether we will reach it becomes almost the wrong question. The better question is what our motion reveals, and what it reveals is that gravity still matters across enormous distances. The universe is expanding, but it is not smooth and empty. Matter has gathered into structures. Galaxies flow toward dense regions. Voids help shape motion by their absence. Dark matter forms invisible scaffolding. Superclusters mark the great valleys of the cosmic landscape. We are not drifting randomly. We are moving through structure. The Great Attractor is one of the signs of that structure. It tells us that the universe is not just expanding like a blank balloon. It is clumpy, webbed, uneven, alive with gravitational history. Every galaxy carries the memory of where matter gathered. Every motion is a clue to what lies around it. Our motion toward the Great Attractor is one of those clues. But there is another reason we will likely never arrive. The distances are too great, and the future is too long. Even if we were moving steadily in that direction, the travel time would be far beyond the lifetime of the solar system in any practical sense. The sun will change long before any meaningful arrival at such a region. Earth itself will not remain habitable forever. The stars of the Milky Way will evolve. The local group will merge and transform. The universe's expansion will continue reshaping what can ever meet what. The Great Attractor belongs to a scale where human words like journey and destination begin to break. We can use them because they help us imagine. But the reality is deeper. This is not a journey like crossing an ocean. It is not a journey like traveling to another planet. It is a flow through cosmic time, a motion that may continue for billions of years without ever producing a clear arrival, a destination that behaves less like a place and more like a direction. That is why the title feels so haunting. The hidden force pulling the solar system is not going to rip the planets away tomorrow. It is not going to drag Earth into darkness. But it reveals that our entire cosmic home is part of a motion so large that arrival may never come. We are moving towards something we may never reach, a destination written into our velocity but erased by expansion, a pull that is real but not final. The universe is full of such unfinished journeys. Light from distant galaxies travels toward us, but some future light may never reach us because space expands too fast between us and the source. Galaxies may feel each other's gravity, but expansion can prevent them from ever merging. Matter may move toward denser regions, but dark energy changes the long-term fate. The cosmos is not only made of arrivals, it is made of approaches, near misses, flows, separations, signals that fade before they arrive, paths that continue without end. The Milky Way's motion toward the Great Attractor is one of those cosmic approaches. It has meaning, it has direction, but it may not have a final meeting. And still, the pull matters. A thing does not need to be reached to shape your motion. The moon shapes Earth's tides without falling into Earth. Jupiter shapes asteroids without touching them. Dark matter shapes galaxies without shining. The Great Attractor shapes our galaxy's motion without becoming our final destination. Gravity is not only about collision, it is about influence. The universe is full of things influencing one another across distance, creating motions that last longer than civilizations, longer than species, longer than stars. This is why the Great Attractor remains so powerful as an idea. It is not dangerous in the simple way. It is not a monster at the end of space. It is a reminder that we are part of something much larger than our local sky. When we look up at night, we see stars in the Milky Way. They seem scattered and still, but beyond them lies the greater structure, galaxies moving in streams, superclusters forming basins, voids stretching like dark oceans, and the entire universe expanding between it all. The solar system is inside the Milky Way. The Milky Way is inside the local group. The local group is inside a larger flow. That flow is part of Laniakea, and Laniakea itself is part of a universe that refuses to stand still. This nested motion is almost impossible to feel, but it is real. If you could see time sped up across billions of years, the universe would not look like a static starfield. Galaxies would drift and merge, clusters would grow, filaments would stretch, voids would widen, light would redden, the cosmic web would evolve, the Milky Way and Andromeda would approach, distort, and merge into a new galaxy. Distant superclusters would become more isolated as expansion continued. The Great Attractor would not appear as a final station. It would appear as part of a moving landscape, a dense region in the web, one of many gravitational influences shaping the motions around it. And our solar system, tiny beyond imagination on that scale, would ride inside its galaxy through all of it. This perspective changes the meaning of home. Home is not a fixed place. Home is a moving system. Earth is home, but Earth moves. The solar system is home, but the solar system moves. The Milky Way is home, but the Milky Way moves. Even the cosmic structures we use as addresses are not permanent. Everything shifts, everything travels, everything changes with time. That can feel unsettling, but it can also feel peaceful, because motion is not necessarily danger. Motion is the normal state of the universe. A planet in orbit is falling forever and surviving. A galaxy in a flow is moving through structure and remaining whole. The solar system can be carried by the Milky Way without being torn apart. The Great Attractor can influence our trajectory without threatening our daily existence. We are moving, but we are not falling into immediate destruction. We are part of the great cosmic drift. This is the calm truth behind the dramatic title. The hidden pull is real, but it is not the end of us. It is not a countdown. It is not a collision course. It is one layer of motion in a universe where everything is already moving. Will we ever get there? Probably not. Not as a destination, not as a final arrival, not as a moment when the solar system reaches a boundary and enters the Great Attractor like a ship entering a harbor. Instead, we will continue moving with the Milky Way, shaped by gravity, altered by future mergers, carried by the expansion of space, and eventually isolated with our local cosmic companions as the distant universe recedes beyond reach. The journey continues, but the destination changes meaning. In a human life, journeys are measured by arrival. We walk to a door, sail to a shore, fly to a city, send probes to planets. We want an endpoint because our lives are short and our paths are local. But the universe has journeys with no arrival. Light travels until absorbed, scattered, or stretched into invisibility. Galaxies move towards structures they may never reach. Space expands faster than distant signals can overcome. Matter falls, orbits, drifts, and flows through time beyond comprehension. The Great Attractor is part of one of those journeys. A direction without a simple arrival, a pull without a final crash, a mystery that teaches us not where we will end, but how deeply motion defines us, and in a way that is more profound. Because if we were simply falling into a giant object, the story would be dramatic but simple. Something pulls. We arrive. The end. But the real story is stranger. We are being pulled by one structure, influenced by another, moved away from emptiness, carried inside a galaxy, bound to a local group, and stretched within an expanding universe. There is no single ending because there is no single motion. Everything overlaps. Gravity and expansion, pull and drift, structure and emptiness, local binding and cosmic separation. The Great Attractor sits at the intersection of all these ideas. It is close enough in cosmic terms to shape our motion, far enough that we may never reach it, massive enough to matter, not isolated enough to explain everything alone, hidden enough to become a mystery, mapped enough to become part of a larger truth. That truth is this: the universe is always in motion, not just the planets, not just stars, not just galaxies, everything. Even the largest structures are part of a flow. Even the emptiest regions help shape the motion. Even the light we receive is traveling through time, stretched by expansion, carrying messages from places that may never be reachable. Nothing is fixed, nothing is final. Everything is falling towards something, moving away from something, orbiting something, expanding with something, or being carried by something larger. And tonight, Earth moves with all of it. You may be still in your room, the air may be quiet, the night may feel calm. But beneath that calm, Earth is spinning. The planet is orbiting the sun. The sun is moving around the Milky Way. The Milky Way is falling toward Andromeda. The local group is moving through the cosmic web, and our larger region is shaped by attractors, repellers, superclusters, and voids. We are passengers inside layers of motion too large to feel. The Great Attractor is not the place we will arrive. It is the proof that even our galaxy has a path written by invisible gravity, a path through a universe that expands while it gathers, a path toward a destination that may never be reached. And perhaps that is the most beautiful part. The journey never ends, not in the way human journeys do. There may be no final arrival, no cosmic doorway, no moment when the Milky Way reaches the Great Attractor and stops. There is only movement, endless movement, through gravity, through expansion, through darkness, through time. And somewhere inside that motion, a small blue planet turns quietly around a star, carrying life through a universe that has never once been still. The Great Attractor is pulling us. That sentence sounds like the beginning of a disaster. It sounds like something hidden in the dark is dragging the solar system away from safety. It sounds like Earth is in danger, like one day the sun and its planets will be torn from their paths and pulled into some invisible cosmic abyss. But that is not what is happening. The Great Attractor is real, and the motion is real, but it is not a threat to Earth. Not today, not tomorrow, not in any human future, not in the way we imagine danger. The distances are simply too enormous. The scales are too vast. The pull acts not on Earth as a small planet, but on entire galaxies and galaxy groups across hundreds of millions of light years. It is not reaching into the solar system and disturbing the orbit of Earth. It is not pulling the moon away. It is not stretching the planets apart. It is not changing the seasons, the tides, the weather, or the quiet rhythm of our daily lives. The sun still holds the planets. Earth still moves around the sun. The moon still moves around Earth. The the solar system remains intact. The Great Attractor is not a local danger. It is a cosmic direction. That is the first comfort. Everything we know is safe from it in the ordinary sense. The pull is so broad, so large, so spread across cosmic scales that we are carried by it the way a ship is carried by a current. The ship does not fall apart because the ocean moves. Everything inside moves together. That is what is happening to us. The solar system is riding inside the Milky Way. The Milky Way is moving through a larger cosmic flow, and the Great Attractor is one of the deep gravitational features shaping that flow. It is not destroying our home. It is showing us that our home is moving, and that realization may be even more powerful than fear. Because once we understand it, Earth stops feeling like a fixed place in the universe. It becomes something else, a moving world, a living planet traveling through space on a journey we did not choose and cannot stop. We are not sitting still beneath the stars. We are being carried. Every mountain, every ocean, every forest, every city, every person, every memory, every quiet night, every sunrise, every breath ever taken on Earth has happened on a planet in motion. Not only around the sun and not only around the Milky Way, but through a greater cosmic current shaped by structures so large that even galaxies become small. This is the philosophical weight of the Great Attractor. It does not frighten us because it threatens Earth directly. It humbles us because it reveals our scale. We live our lives in places that feel solid and permanent. A room, a street, a city, a country, a coastline, a mountain, a home. These things feel fixed because human life is short and local. We return to the same places. We see the same sky. We recognize the same horizon. The ground feels steady beneath us. But the ground is not steady in the cosmic sense. It is moving. The entire Earth is spinning once every day. It is orbiting the sun once every year. The sun is moving around the center of the Milky Way. The Milky Way is moving with the local group. The local group is moving through the cosmic web. And beyond all of that, our larger region of space is influenced by attractors, repellers, superclusters, voids, and dark matter. Stillness is only what motion feels like when everything nearby is moving with you. That is why we do not feel the Great Attractor. We are not being pulled separately from the world around us. We are not being left behind. Everything local shares the journey. Earth, the Sun, Jupiter, Saturn, the comets, the dust, the spacecraft, the outer planets, and the faintest objects at the edge of the solar system are all traveling together inside the same larger motion. We are passengers inside passengers. Earth carries us. The Sun carries Earth. The Milky Way carries the Sun. The cosmic web carries the Milky Way through gravity and expansion. And somewhere beyond the bright veil of our own galaxy, the Great Attractor remains part of the direction. That thought is both enormous and quiet, because nothing about your night changes when you know it. The room remains the same. The stars remain calm. The moon, if it is visible, still hangs in the sky with its familiar pale light. The air still moves gently. Life continues. And yet, the meaning underneath everything changes. You are not simply living on a planet. You are traveling through the universe. You always have been. Every human who ever lived was born on a moving world. Every ancient civilization, every quiet village, every explorer, every poet, every scientist, every child looking up at the stars, all of them were passengers on the same journey. They did not know the name of the Great Attractor. They did not know about superclusters or cosmic flows. They did not know the Milky Way was being pulled through a larger structure, but they were moving with it. The journey existed before we understood it. That is often how the universe works. Reality does not wait for us to name it. Gravity was pulling before humans knew what gravity was. The Earth was orbiting the Sun before anyone proved it. Galaxies were moving before anyone measured redshift. The cosmic microwave background filled the universe before any instrument detected it. The Great Attractor shaped motion before astronomers realized that something was strange. Discovery does not create the universe. It removes our blindness. And the blindness, in this case, was partly caused by our own home. The Milky Way, beautiful and enormous, blocks part of the view beyond it. The same galaxy that carries us also hides what lies behind its dusty plain. Stars, gas, and dark clouds create the zone of avoidance, a region where ordinary visible light astronomy struggles to reveal the deeper universe. It is strange to think that our galaxy is both a home and a veil. It gives us the sun. It gives us the stars of the night sky. It gives us the environment where Earth could exist. And yet, when we try to look outward, it hides part of the cosmos from us. Behind that veil, scientists have searched for decades. They have used radio waves, infrared light, X-rays, galaxy surveys, velocity maps, and mathematical models to understand what ordinary vision cannot show. They have found hidden clusters. They have mapped flows. They have connected the Great Attractor to larger structures. They have realized that Shapley, Laniakea, and the dipole repeller are all part of the story. But the search is not over. The universe is still hiding things. New telescopes will continue to look through the zone of avoidance. Radio astronomy is especially important because radio waves can pass through dust that blocks visible light. Where our eyes see darkness or confusion, radio telescopes can reveal hydrogen gas, hidden galaxies, and large structures buried behind the foreground of the Milky Way. One of the most important future tools is the Square Kilometre Array. It is planned to become one of the most powerful radio telescope systems ever built, spread across huge collecting areas and designed to listen to the universe with extraordinary sensitivity. It will be able to map cosmic hydrogen across vast distances, reveal hidden structures, and help astronomers understand how galaxies are distributed, even in regions that visible telescopes cannot easily explore. For the Great Attractor mystery, this matters deeply, because the more completely we map the hidden universe behind our galaxy, the better we understand what is pulling us, not as a simple answer, not as one dramatic object, but as a full landscape of matter. The Square Kilometre Array and future surveys may reveal galaxies we have not yet counted. They may show filaments passing behind the Milky Way. They may uncover clusters that were only partly visible before. They may improve our understanding of how the Great Attractor region connects to larger structures beyond it. And perhaps they may show that even our current map is still incomplete. That is one of the most exciting possibilities. The Great Attractor once seemed like the great hidden source of our motion. Then scientists discovered that it was not enough by itself. The Shapley Supercluster made the story bigger. The dipole repeller made it stranger. Laniakea gave us a larger cosmic address. Dark matter gave the structure invisible weight. But what if there are still larger structures contributing to the flow? What if behind the dust, beyond the current maps, or at the edges of our surveys, There are patterns we have not yet fully recognized. The universe has surprised us before. It will almost certainly surprise us again. Every generation of astronomy has thought it was reaching the final map, only to discover a deeper layer. Earth was once the center, then the Sun, then the Milky Way, then other galaxies, then clusters, then superclusters, then the cosmic web, then dark matter, then dark energy. Each discovery did not make the universe smaller. It made us smaller inside a larger truth. That is not discouraging. It is beautiful. It means the universe never runs out of things to astonish us. The Great Attractor is part of that tradition. It began as a mystery of motion. Something was pulling. Galaxies were moving. Our region of space had a peculiar velocity that demanded explanation. The source was hidden behind our own galaxy, and the more astronomers searched, the more the mystery expanded into a story of superclusters, voids, dark matter, and cosmic flows. It is the kind of discovery that changes how we feel about location. Where are we? The simple answer is Earth. A deeper answer is the solar system. A deeper answer is the Milky Way. A deeper answer is the local group. A deeper answer is Laniakea. And deeper still, we are in motion through the cosmic web, shaped by the gravitational pull of immense structures and the expansion of space itself. Our address is not a fixed coordinate. It is a journey. That is what this means for us. Not danger, perspective. The Great Attractor does not threaten your life. It does not threaten the Earth. It does not disturb the solar system in any practical way. It will not appear in the sky. It will not swallow us. It will not tear apart the Sun's family of planets. But it does something more subtle. It changes the emotional shape of the universe. It tells us that everything familiar is part of a motion beyond our senses. It tells us that the Milky Way itself is not a final home, but a moving participant in a larger structure. It tells us that there are forces shaping our cosmic path that we cannot see directly and may only understand through patience, mathematics, and instruments designed to look beyond ordinary light. There is humility in that. Humanity often lives as if the world is the whole story. Our problems feel enormous because they are close. Our histories feel ancient because human memory is short. Our borders, languages, cities, and lifetimes feel solid because we experience them from inside. But astronomy stretches the mind outward. It reminds us that Earth is a planet, that the planet is moving, that the Sun is one star, that the Milky Way is one galaxy. The galaxies move in rivers, that the rivers are guided by hidden mass, that the universe is larger than any instinct we were born with. This humility is not meant to make life feel meaningless. It can do the opposite. It can make life feel precious. Because if we are small, then every moment of awareness is remarkable. If Earth is a tiny moving world inside a huge universe, then the fact that anything on Earth can understand the motion is extraordinary. If the Great Attractor is pulling entire galaxies, and yet a mind on one small planet can ask what it is, then our smallness is not emptiness, it is wonder. We are not powerful compared with superclusters, but we are aware. We cannot stop the motion of the Milky Way, but we can measure it. We cannot see everything behind the zone of avoidance, but we can build instruments to pierce the veil. We cannot reach the Great Attractor, but we can understand that it is there. That is our place in the universe, not masters of it, not centers of it, but witnesses, temporary witnesses on a moving world. And perhaps that is enough. The Great Attractor also teaches patience. Its story cannot be understood in a single image. It requires measurements taken over decades. It requires maps of thousands of galaxies. It requires looking in wavelengths the eye cannot see. It requires accepting that the first answer may not be the full answer. The universe is too large for quick conclusions. The Great Attractor was not solved by pointing one telescope and seeing one object. It was approached slowly, through motion, through hidden structures, through larger surveys, through new ideas like Laniakea and the dipole repeller. The mystery became more accurate as it became more complex. That is something worth remembering. Simple answers are comforting, but the universe often gives us deeper ones. At first, something is pulling us. Then, the Great Attractor is pulling us. Then, the Great Attractor is a region, not an object. Then, Shapley contributes strongly. Then, voids matter too. Then, dark matter dominates the structure. Then, our motion belongs to a cosmic web. Each layer makes the picture less simple, but more true. And truth, in astronomy, often looks like vastness. So, what does the Great Attractor mean for us tonight? It means that the sky above us is not just a ceiling of stars. It is part of a moving universe. The stars of the Milky Way hide deeper galaxies behind them. Those galaxies gather into clusters. Those clusters form flows. Those flows reveal the hidden architecture of matter. It means our solar system is not isolated. It is embedded in a galaxy, and the galaxy is embedded in something larger. It means we are being carried toward a direction we never chose, by gravity that began shaping the cosmos long before Earth existed. It means we may never fully see the entire source of the motion with perfect clarity. Because the universe is complex, our view is limited, and every improved map reveals new structures beyond the old ones. But it also means we are learning, slowly, carefully, beautifully. Each telescope gives us a better view. Each survey fills another dark patch. Each model brings the flow into sharper focus. Each new instrument pushes a little farther through the zone of avoidance. And perhaps one day, the hidden regions behind the Milky Way will be mapped in such detail that what once felt like a cosmic ghost will become a known part of our galactic neighborhood. But even then, the wonder will not end, because beyond that map will be another map. Beyond that structure, another structure. Beyond that question, another question. The universe does not run out of depth. That is one of the most comforting thoughts in science. There will always be more to understand, not because we know nothing, but because what we know opens doors. The Great Attractor, Shapley, Laniakea, dark matter, the cosmic web. Each answer expands the mystery instead of closing it. And tonight, that mystery is carrying us. Right now, this moment, the Earth beneath you is moving through space. The solar system is moving. The Milky Way is moving. Our galaxy is not drifting aimlessly, but flowing through a cosmic structure shaped by invisible gravity and vast concentrations of matter. You do not feel it. You do not need to. The journey is too smooth, too large, too ancient. But it is happening. And there is something peaceful in knowing that. The universe is in motion, and we are part of it. Not separate, not outside, not watching from a distance. Part of it. The atoms in our bodies came from stars. The planet beneath us formed from ancient debris. The sun carries us through the galaxy. The galaxy carries us through the cosmic web. Even our thoughts about the Great Attractor are made from matter that belongs to the universe, trying to understand itself. That is the quiet beauty of the whole story. The thing pulling us is not an enemy. It is part of the same universe that made us. Tonight, as you drift to sleep, imagine the solar system from far away. Not the way we usually see it, with planets drawn in neat circles around the sun, but as a moving system carried through darkness, the sun glowing at the center, Earth turning quietly in its orbit, Jupiter and Saturn far beyond, Neptune at the edge of the familiar planetary family, comets drifting in the cold, and around all of it, the Milky Way, a vast spiral of stars, gas, dust, and dark matter, and beyond the Milky Way, the local group, and beyond that, Laniakea, and beyond that, the cosmic web. Now imagine all of it moving, not falling into disaster, not rushing toward an end, but flowing, pulled by massive structures, guided by invisible gravity, carried through a universe too large to hold in the mind. Somewhere beyond the stars of our own galaxy, beyond the zone of avoidance, beyond the places our eyes cannot reach, there is a gravitational direction written into the motion of galaxies. We cannot see it clearly. We cannot reach it. We may never fully understand every part of it, but it is there, patient, enormous, ancient, shaping the path of everything we have ever known. And tonight, as you close your eyes, that journey continues. Earth keeps turning, the sun keeps moving, the Milky Way keeps flowing, the universe keeps expanding, and we remain passengers on the most extraordinary journey imaginable, across a cosmos far stranger, far larger, and far more beautiful than anything we could have dreamed. Good night.